This is debugging Apache Spark in Python. For me, it's really sad when I write Python code and get back a JVM stack trace. I don't know. So I'm really curious, how many people are actively using PySpark? Oh my God, that's so many people. Yay, I love you all, and I'm really sorry. Oh God, yeah, okay, cool. So yeah, I'm Holden. My preferred pronouns are she or her, and I'm a Spark committer as of January, which is really, I'm very happy about this because it took like 4 years, but whatever. I have some Spark books, as was mentioned, and I will try and get you to buy the one which I get the highest royalties on, of course. And you can follow me on Twitter. It's mostly sort of complaints as a Canadian living in America going like, what the hell are you doing? But if you want more professional things, the slides from today's talk will be on my SideShare. And if you want to pretend to be business people, you can find me on LinkedIn and we can say business to each other. It's, I don't know what it's for, but whatever. For the people who aren't already using PySpark, I have some Spark videos, including an introduction to PySpark video, and hopefully this talk does not scare you away from PySpark, although if I'm fair, it probably would scare me away. So we normally save the debugging talk for once we've converted enough of you. And sort of just on a complete tangent, I added this slide after the election in America. I'm trans, I'm queer, I'm Canadian, and I consider myself part of the leather community. And like, this isn't super important for software, but just like, if you don't know people like me, we're here, we're not as scary maybe as television says we are. I don't know what your television is like, but in America it certainly says a lot of things about people like me. And I think we're actually really friendly, and so please don't murder us in our sleep. And okay, cool. Moving on, yeah, I work at the IBM Spark Technology Center. I put this slide in so they keep paying for my travel, which is very nice of them. I have this graph that goes up and to the right that shows the amount of work we do on Spark. And so it's a very nice graph. This also helps me keep getting paid. And so there's about 50 developers and 25 designers, which is an interesting ratio. It's a lot of fun. If anyone's for some reason looking to relocate to America, come talk to me. But I imagine that's a tough sell right now. I don't know. Maybe you've got friends there, though. That's legit. Yeah, and here's another slide, which implies we do a lot of work in Spark. And if you buy something from IBM, whatever it is, keep buying it. I don't know. I think we sell mainframes and support contracts, and you definitely want 6 of those. And Power PC or something. Anyways, yeah, cool. Yeah, okay, so I'm hoping you're all friendly people. This is a Python talk, and Python people are normally very friendly, so just fake it if you're not. If you object to cats or stuffed animals, this is probably not the talk for you. The other talk looked really cool, and I won't mind if you just like are like, no, it's cool. And I'm really excited so many people are already using PySpark. And hopefully you're okay with things getting a little bit silly because I don't know how to do serious. Yeah. So we're going to talk about sort of how PySpark works behind the covers, where all the gremlins hide out. And we're going to talk about how this impacts our debugging. We're going to look at how to find the logs and sort of how to persist them. We're going to talk about how to add our own logging. And then we're going to talk about trying to understand the error messages from Spark. And that's probably why you're here. And I'm going to try and get you to buy my new book because I think everyone should have many copies of it. Alternatively, we can think about this as building our monster identification guide. So I like to think that there's a bunch of monsters hiding out in pretty much every big data toolchain ever. And so we're going to go, this one's Boo. Boo is the Python stack trace from our driver program. This one's Friend Monster. Friend Monster is the JVM stack trace. The JVM stack trace comes along with every other stack trace to keep your stack traces from getting lonely. And we brought Friend Monster with us today. And Boo. And then this is Tubbs. Tubbs had to stay back in America, but Tubbs is the out-of-memory exception because Tubbs just likes eating all of our memory. And this is Buddy. Buddy is the really helpful logging mechanism in Spark that likes telling you things like the sky is still blue and did you know I'm connected to a cluster? Has anyone had to turn down the default logging in Spark? That's not everyone? Okay, whatever. But yes, we all know and love Buddy. She's very talkative. But let's look at how PySpark is built. And this is going to be kind of terrifying, kind of like this playground here, right? Like, I don't think this was actually designed for children, but PySpark is kind of like if you let your kids play here. Child Protective Services would come and take them away. And thankfully, we don't have that for big data. So yeah, that's fun. So Spark itself is written in Scala for the most part. And so PySpark is actually this really, let's call it interesting, solution of bolting Python on top of that and underneath it, and just trying to pretend as much as possible that this JVM doesn't exist. We just like close our eyes and say la 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 la. And this is done with Py4j. Has anyone used Py4j? Wow, 4 people. That's really awesome. I love Py4j, but also it's really terrible. But it's also the best thing there is. It's like most software, right? Like, I hate it because I use it, but I also am really glad it exists. But we get really delightful exceptions from Py4j that don't make a lot of sense. Then on top of that, we add our own healthy dose of magic. And when the magic works, our job finishes. And when the magic breaks, we're lost. Spark SQL avoids some of the magic that we have to do by just doing a different kind of magic. So instead of doing this wonderful thing here, Spark SQL just like does all of its computation in the JVM as much as it can. But essentially, PySpark works by having this Py4j bridge from the Python VM to a Java VM that distributes your code out to a bunch of workers that then has pipes from the JVM to Python VMs copying your data. And then if anything goes wrong, right, it essentially just gets wrapped up in every single one of these, each coming back and telling you their own little bit of where it failed inside of this. So if I get a failure inside of here, I get like 4 stack traces. And that's if I'm lucky, right? I'll normally get 4 stack traces multiplied by the number of workers I have, and then multiplied by 2. And that could be like 100 workers. So I might get 800 stack traces for like a really simple thing, right? And this is really overwhelming as a developer. I'm just like, what the hell is going on? Yeah, and so that's why our life is terrible. But we're going to try and make our lives less terrible. The important one for today is, yeah, our error messages make no sense. And then there's a bunch of other things that also sort of impact your life, but we're going to pretend they don't exist for the purposes of today. Yeah, okay, yeah. So one weird trick to debug anything. Even though we're working in a distributed system, I think the best thing that we can do for ourselves is at the start, instead of just jumping right into the logs and looking at the different stack traces, because it's really easy to pick the wrong one of the 800 we got back, is building a like kind of shitty mental model of what we think our code is doing. It doesn't have to be very good, but just like think like, what is my program trying to do? And then going and looking at the logs after you've built that model, rather than the other way around and being like, oh, it's not doing what I thought it was there. Is that okay? And yeah, just repeating this process a few times until you give up and go and become a corn farmer in Iowa, or like just decide that subsampling your data is okay and whatever, big data is a fad anyways. Either one's fine. But let's look at where we're going to find our logs. So for those of you that have turned down your logging level in Spark, you've probably been working in Spark's delightful console. And that's the one where Buddy is just going to give us all of our error messages all of the time, intermixed with messages about every single like block that is being copied around the cluster. So it's just kind of really overwhelming. But our error messages are reported to the console along with a lot of other useless crap. The Spark web UI is a lot better place to find our error messages because it's sort of not intermixed with all of this like random logging crap, and we can just focus on the error itself. Is anyone working in Jupyter with Spark? Wow, that's like everyone. And so now this part is sad. The error messages were so useless, I looked up how to disable error reporting in Jupyter. Someone told this to me about like 4 months ago, and it made me really sad on the inside, and I hugged Boo, and we talked it out, and it's okay. But if you're working in Jupyter, you got this problem where you get error messages in Jupyter, but the part of the error messages that you get is the part without the useful information. You get essentially just the error message coming from this part right here. And everything else that's back here doesn't really show up inside of your Jupyter error messages. So you just get kind of sad and you're like, this error messages makes no sense. And so it's okay. Just go to the random console where you launched your Jupyter instance from, and you can find your error messages. And that's totally intuitive, right? And if we're working in a cloud solution, that's really easy to do, right? I'll just like ask my administrator to pass the screen session to me. They'll do that. What could go wrong? In all seriousness, if you're working in a cloud solution, hopefully whoever this is has actually implemented like a correct solution to this where they pick up the log messages and actually make it available to you somewhere. If they don't, tell them to look at Spark-19094 and steal that code. And then they can make the log messages available to you, or just switch to a different cloud vendor. I don't even know if IBM does this correctly. I hope we do. If it's IBM, don't switch to a different cloud vendor. They're perfect. Okay, so for people that are working in Yarn, we have to go about getting our logs in a little bit of a different way, or at least we can. Yarn log collection works at least some of the time. In the clusters that I have to set up myself, Yarn log collection works 0% of the time. In the clusters where I get like a Hadoop administrator to set it up for me, it works like at least 50% of the time. And then you can just use the magic incantation yarn log space application dash random string of numbers that is reported to you at the start, and you can get your logs. But really what you want to do is you want to set up the Spark history server. And I should probably stop wandering off of the podium. I'm sorry to whoever's doing the camera. But the Spark history server is amazing. It essentially gives you the Spark web UI after your job has failed. And that's normally when we want to like actually debug our job, right? Spark by default, what happens is while we're running, we've got this really nice thing. I can click in, I can see what's going on with my workers until my workers fail and exit. And then I can't go look at their logs anymore. And then I'm like, wait, but oh. So you want to turn on the Spark history server. And essentially there's 5 different knobs that you have to change. And it's different for everyone. And you're just going to change those 5 knobs until it works. And then don't touch it. Just don't. And hope it never breaks. Alternatively, for people working in Yarn, you can set this magic debug delay sec thing to a higher number, and you can just SSH to your container and like debug it old school. And if you're finding your Yarn log collection isn't quite working the way you think it should be, try bumping up this number randomly. Sometimes it helps. Magic. Yay. This isn't all just random shit to do, but a lot of it is. I'm sorry. So yeah, Spark is very verbose by default. And the first thing that we're going to want to do, now that we've figured out where our logs are, is make it so that our logs contain not just random crap. So if you just leave Spark's default logging on, it's just going to tell you everything happening in the world. And its other mode is telling you pretty much nothing. So it has like one big knob with 2 settings, neither of which are the one we want. But we can use this dynamic tunable knob, and instead of just changing it in our properties file at the start of our job, we can dynamically increase the logging to something useful when we get to the part of our code where the errors are happening. This is a lot easier to do and makes more sense in a notebook or an interactive job. And if you're working in sort of a batch job, you're pretty much screwed and you have to read shit tons of logs. But in interactive mode, sc.setLogLevel will let you tune it up when you get to the part of your code that's failing. Okay, so what about when we actually get our error message? How are we going to understand it? So yeah, the Python stack trace and friend monster are going to be the 2 things that we focus on initially. The JVM stack trace. Right. So the JVM stack trace comes because it doesn't want our error messages to get lonely. And for the most part, it doesn't, I mean, Friend Monster is really cute. She is, but she's not really useful. For the most part, the JVM stack trace is really just sort of a carrier that we can ignore. But we'll talk about the kinds of errors where we actually need to pay attention to the JVM stack trace. And we're going to make a really, really simple error in a transformation and look at sort of how to find the meat of our exception and where this all lives. So I'm going to divide by 0. This is going to go poorly. I'm dividing integers by 0, and so badness. So I know where my error is because I've started out already. But if, like, I was doing x divided by y or something, you know, crazy big data stuff, this could go like a lot worse. So if I run this code, I get 400 lines of exception. And if we look at this, at least reading from the top down, there is nothing in here that is useful to me. Somewhere in the 400 lines there are, but it's nowhere near the start of the exception that I'm getting back. This is all just stuff about sort of Spark's internals that are being wrapped around our own code that is telling us about and how these internals have been impacted by our failure. So if you see things like this, don't like assume it's an error in Spark. I mean, there's a chance it is, but I'll blame it on you anyways. But like when you see these errors, it probably means your error is actually hidden deep within. So we're going to go to the Spark Web UI instead. Or if you're one of the fancy people with the Spark History Server, you're going to go to your Spark History Server. And so we see we've got our stage here, it failed, and our failure reason is also crap. Okay, but there's a thing and I can click on it, and maybe if I click on this thing, I'll get something useful. Oh my god, I clicked on a thing. So what we do is we click on a thing and then we can see, okay, these are the things that actually failed on my workers, right? And this is probably, if I have things that are failing on my workers, that's probably my problem. The error message that's being reported from my driver probably isn't what I care about. So it's probably going to be in here. And this is still not very useful, but it's shorter than 400 lines, so it's a start. Then I'm going to scroll almost to the bottom, which is definitely a usable metric for everyone. And then we find our actual exception. We find that I called my thing bad PySpark because I'm not very imaginative, and we got a 0 division error. And if you want to find this in your own code, you actually search for the magic string org.apache.spark.python exception : and Python exception is camel case because Scala developers. Yeah, and so that's how you're going to find the error message that's happening on the innermost part of your worker exception. And this is pretty easy. For this case, we don't even have to really pretend to make sense of a JVM stack trace. We just have to ignore it. And that's my favorite thing to do with a JVM stack trace, is pretend it doesn't exist. It's not going to work all of the time, but it's going to work pretty often. For console people, you can like search in your screen session. Please don't, just use the web UI. But you can search in there, and the error message is reported in your console logs. But it's not worth it. So why does this error message make so little sense, right? Like, why do we have, when we run this locally, all of this crap coming back to us? This is because we do some really cool stuff for performance. Vroom, vroom. And this performance only costs us when things go wrong. And if we didn't do this cool stuff for performance, we'd lose a lot of benchmarks, so we're not going to stop doing it. Because benchmark-driven software development is like, that's life. So essentially what happens is we need to pipeline our Python code. And we need to do the pipelining inside of Python in a way that's mostly opaque to Scala. In Scala, when we put these two map transformations together that we showed on the example of sadness, what happens is this is pipelined inside of Scala, and it actually knows which different piece is executing when it fails. Inside of Python, what we tell the Spark Scala runner is, I have a Python job. It contains some code. You don't have to worry about it, but just like run this thing. And if we broke this up into smaller pieces so that we could see which part of our Python code was failing easily, we would have this problem where we have to copy the data from Python into the JVM and sort of back again twice rather than once. And copying data is kind of expensive. Even on a local machine, it's going to slow us down. So we do this like sort of pipelining eagerly inside of Python, and that's why our exceptions are really confusing. But sometimes we've got a bunch of map transformations chained together, and I don't know which one is failing, right? Like I don't know why this thing is going wrong. And there's a thing that we can do. We can change our code so it'll break pipelining while we're debugging, right? And then we're going to take it out afterwards because we want our code to run vroom, vroom fast. That's why we're using Spark. And what we're going to do is if you just tag the intermediate RDDs as cache or persist, Spark has to evaluate that entire thing sort of on its own, copy that to the JVM, and then store it in memory. And by doing this, it evaluates each transformation sort of one at a time rather than sticking them all together. And so then we can figure out which one is actually failing. The other one is you could just move a take one around. That works if your transformation fails 100% of the time, right? Like we were dividing by 0, that's going to work there. But if we've got something which fails on like some of our input data, but not all of it, you're probably going to want to do the little cache thing and move it around so that you can like actually see which part of your code is failing. The other part is I love Lambda expressions. I'm a recovering functional programming person. I still go to meetings. They haven't given me the chip yet because I keep writing Lambdas all the time. And really, the problem is Lambdas are really fun to write. I don't like writing def, and if I write a Lambda, I can pretend that I don't need to test my code. It's just a Lambda. Everything's fine. Stop asking questions. No, this doesn't need a doc string. It's really simple. But the problem is Lambdas make debugging hard, especially when we have all of these chained operations together. Even if I persist the intermediate RDDs, if I'm using Lambdas, it's going to be hard to figure out which piece of my code is failing. So if you find yourself debugging a part of your code, that's probably time to rewrite it from Lambdas into functions with names and doc strings, and maybe even tests. I'm just saying. And I like to say that rewriting code from Lambda to a name function never broke anything, and that's like a blatant lie, but it's close enough to true that you should do it anyways. And if doing that rewrite breaks something, you were doing something really interesting that you should not be doing probably. And this is a good time to stop doing that. Please test your code. So you probably don't want to spend your life looking through JVM stack traces, trying to find the inner Python failures, or wondering about like what this file not found exception is, or why I'm running out of memory. If you test your code, you spend less of your time debugging. And you don't have to get aboard the SS failboat. The failboat is not a fun boat to be on. It is the boat where my pager goes off at 2 o'clock in the morning, except now I shrink wrap software, so I don't have a pager. But in anticipation of when I do have a pager again, you should really test your code. It will make your life a lot easier, and it will help avoid the next global financial crisis wherein I can no longer pay my rent. So there's a bunch of different libraries to do testing. Spark Testing Base is the one that I'm a co-author of, and I think it's great because I'm a co-author of it. I don't make any money on this though, so like I'm totally fine if you use another one. Books will talk. But testing libraries, there's like 2 other Python ones, and just pick whichever one feels more authentic to you, whichever one you really like working with. So that's great. We've seen that Spark's logging messages are not super useful, so it's probably going to be time to add our own. Java users can use log4j. If there's any like Closet Scholar or Java users hanging out here, it's okay, we can be friends. And I'll buy you a drink maybe if there's not too many of you, and we can reminisce about out-of-memory exceptions. Python users use a logging library. There's one called logging. It works in Spark. It's really easy. You can just use print statements too. I won't even judge you. Like, just put something in there. Don't depend on Spark. Has anyone used Spark accumulators? Okay. I really hope none of you do anything related to finance or things that impact my life. Yeah, it's a bit late. But accumulators behave weirdly, but they're fine for debugging. Because debugging, if I'm off by 10%, whatever, that's close enough. But if you're maybe paying people with accumulators, you might not want to use it for that. Unless you're paying me. Accumulators are amazing, and we can talk. But, you know, other people, please do not use accumulators. So I think it's important to distinguish between hard errors and soft errors. Everyone who's ever given me JSON data has been lying to me about what the schema is. They're always like, this is my schema. And I'm like, is it? And they're like, yeah, totally. I'm like, is it? And then they're like, yes. And then I'm like, so I ran this job and it failed. And they're like, well, I mean, I said it's the schema, but like, I gotta go. So what you want to do is, there's a lot of errors where you don't want to halt your job, right? You don't want to throw a Spark exception and like have to debug everything. On the other hand, you also don't want to just throw away all of the invalid records, because one day someone might change their schema for all of the new records. And then, you know, maybe it was okay that you were throwing away 5% of your records before, but now you're throwing away 90% of your records. And that's like not going to be so good when they don't get paid. Like 5%, whatever, we can blame it on them or their banks. But 90%, like there's going to be pitchforks at my office. Yeah. So accumulators, this is the one like reasonable case for using accumulators in my mind, is we can keep track of the number of things that I'm rejecting. In this case, we're going to reject everything because I'm just dividing by 0. This isn't super exciting. But if we had some actually more complex computation inside of here, or we were doing some type of parsing inside of here, we can keep track of our errors, and we can like halt our job if we get an unexpected number of errors. And we should definitely log what's going on, right? Like I want to know what my rejected records were, because if like I rejected the CEO's thing, I'm going to have to debug it personally later. But, you know, it's not too bad. We don't have to halt our job every time we encounter an invalid JSON record. Because if that's my life, I'm just going to spend my entire days cursing the names of everyone who ever gives me data. And that's not really good for either of us. Yeah, this is pretty basic. So why are accumulators bad? Essentially, accumulators are bad because of double counting. And double counting here could actually mean up to j times, where j is defined as the number of actions performed on any downstream RDD referencing this, kinda. And it can change sort of dynamically. It depends, like, if I have node failures in my cluster, the counting can increase. And so, like, I can get j times the number of invalid records reported to me. And normally j is like 5, and if I have a 5x increase, like, that's okay, right? Like, I'm rejecting 10 records. Everything below 100 is fine. But if I'm using this for something important, a 5x difference is going to make a huge sort of change in my life. If anyone's really interested in using accumulators to do useful things, I have a pull request, and there's someone in Chicago who needs to review it, and I'm going to Chicago in 2 weeks, and you can come with me and try and convince him to review this pull request. More realistically, you can just like wait a year. But essentially, accumulators, wonderful for debugging, don't use in prod. -mtrace, don't use it in PySpark, it's not going to work. It's very sad. First off, it would give us back way too much stuff. The other part is, for internal reasons, it's just not going to work. Okay, so out of memory exceptions. We're going to start to get to the point where we can't just ignore the JVM exceptions. And this is going to be tubs. Tubs is our friend. How many people have had an out of memory exception in Spark? How many people have not had an out of memory exception in Spark that use Spark? 4 people. You're lucky. So that's really good. Either you have like a lot of money or not a lot of data. Either one of these is fine. Or you're just like exceptional programmers, in which case San Francisco isn't that bad. So out-of-memory exceptions are one of the cases where we get a JVM exception. This can happen a lot during things like joins. We'll get things like GC time limit exceeded. Has anyone got an application overhead exceeded? I'm sorry. Yeah, that can be a wonderful one because it's an exception message that doesn't even come from inside of Spark itself. It comes from our good friends over in Yarn. And we can get an out-of-memory exception from the JVM on our driver program, which is very confusing. And let's talk about why these things are going to happen so we can sort of recognize what might be going on. So on workers, unbalanced shuffles are like a really big reason for out-of-memory exceptions. And in PySpark, this happens more commonly because we do some stuff to sort of save on serialization costs because pickling is sort of expensive. We do batch serialization and we do some kind of funky stuff to try and make it okay, but sometimes, as previously discussed, the magic fails, and then it's sort of on you at this point to fix it, because like, I don't know, I'm not going to fix it. And essentially what happens is you're going to need to increase the number of partitions that are being used to work around this problem. Buffering of rows with PySpark and UDFs. If you're a Spark SQL user, you can get an out-of-memory exception by doing a UDF if the amount of data that is not being copied to Python is really big, which is very confusing because I'm used to thinking of like out-of-memory exceptions when I'm working on too much data. But in this case, I can get an out-of-memory exception for working on too little data. And that's like kind of not, so I don't remember what words I can use and still be within the code of conduct, so I'm going to not swear, but pretend I'm swearing like a sailor. So essentially what you need to do in this case is you're going to select the subset of data that you want to work with, and you're going to rejoin it with the data frame manually to work around this. And this happens because we do some really cool stuff to avoid copying all of the data that you don't need to Python and just copy the bit of data that you do need. The only problem is we didn't implement the buffers correctly, and sometimes they run out of memory, and you're going to get an out-of-memory exception in this case. Jumbo records. Yeah, if you try and serialize the world, it goes kind of badly. Essentially, this happens surprisingly often in Spark. Essentially, our classes reference something in some scope that we weren't remembering, and then Spark goes, okay, I'm going to go serialize that. And then it turns out Spark serialized all of the records that were returned from my database, and then I have an out-of-memory exception. That one's kind of difficult to debug, but if you look in the Spark web UI, or normally the Spark history server, because at that point your job has disappeared and all of your workers have also disappeared, you'll see that the amount of data being transferred really doesn't match your expectations. And like that can be totally fine in values of like 5x to 10x, just because of the way how serialization works. But if you start to see things like 100x more data than you were expecting in your RDDs, like that's probably a good time to go and look and see if you're maybe accidentally capturing some extra information. This one's a big one, especially for those people who have had the application memory overhead exceeded. Insufficient memory reserve for Python workers. If you're running in Yarn, Spark reserves 10% of the data, 10% of the memory for your Python process, and keeps the rest of it for the JVM and sort of miscellaneous stuff. And that's not very useful, right? You essentially have to do all of your computation in only 10% of the memory that's available on your machines. And the reason why this is picked is that for the most part, most people using Spark aren't nearly as cool of all of y'all, and they're just writing it in Scala or Java. And so leaving 10% for the Python VM is like, that's fine. But for all y'all, you're going to want to change that to be like 20 or 30%. Native code memory leaks. Yeah, calling Fortran, it's a thing. Sometimes I call Fortran incorrectly, and then that library from the 1960s just leaks a bunch of memory. And when that happens, I normally try calling a different Fortran library. I tried to debug it once, and that was not on. So if you have a native code memory leak, it's going to be kind of sad, but you're also going to get the application memory overhead exceeded error, or like it's going to be killed by the kernel because it's using too much memory. And in those cases, you can just see that the Python VM is using a lot of memory, not the JVM, and then this is probably what's going on. Is anyone using map partitions? Okay, you and I will talk after. Okay, there's two, so we'll talk afterwards because we're running low on time, but there's some interesting things about map partitions for debugging. This is my favorite JVM exception because it makes sense. I haven't found a second one, but this is the one that makes sense. So if you try and load an invalid path in Spark, you get a JVM exception. And it's the best JVM exception. It says invalid input exception, input path does not exist. It told me what happened. It didn't just say there was an error inside of MapReduce. I mean, the org, Apache, Hadoop, MapRed, okay. There's a lot of stuff that I just have to skip reading because it's Java, but it told me what went wrong. Anyway, sorry. So I love this exception. It's really friendly, and this is the one time that Fred Monster just really comes by herself. It's just a JVM exception, and it's a JVM exception that makes sense. So she just comes and says hello. And make sure to be her friend. She told you something useful this time for a change. Sorry, friend monster. Okay, so we talked about a bunch of random things in Spark. We talked about like why some stuff can go wrong. There's a bunch of sort of traditional Spark debugging things that a lot of people might talk about doing. If you look at Spark debugging blogs, they'll say things like, look at the DAG. That's not going to work so well for Python users because of the pipelining stuff that we talked about earlier. The sampling data and running locally is actually really good for Python users and Java users. This is fine provided that my issue is not related to the fact that I have big data, and if my issue is actually related to big data, then I'm kind of screwed. We can try connecting a Python debugger, and you're gonna have to change your code a bit, but you can use a broadcast with a singleton to start a Python remote debugger and connect to it, and it works at least some of the time. If you're having a Java exception come back and you're like really adventurous, you can definitely attach a debugger into Java, but that is the path of madness. And so normally I try changing my code until that doesn't happen. Yeah, so this hack is pretty good, and you can use it with your favorite Python remote debugger. And you just use a broadcast variable with a singleton. It's okay. Here are some books. I receive royalties for many, but not all of these books. One of the ones that I don't receive royalties for that I think is quite good is called Learning PySpark. Admittedly, my friend received royalties for it, and I owe him a beer. And hopefully this like absolves us, Denny. But yeah, it's called Learning PySpark. It's by Denny Lee and Thomas. It's a good intro book. For most of you, you came to a debugging talk, you're probably past the intro to Spark stage. But if you've got some friends who are getting started with PySpark, I think it's a good book. Obviously, I think coming soon, High Performance Spark is the best one, and you should buy several copies of it. And in fact, I will show you a link to buy it shortly with. I'm going to do something that authors don't normally do. I'm going to tell you, please don't buy fast data processing with Spark. It's for Spark 0.7. It's kind of old. I still get money for it, though, and the anti-bribery training told me I can't receive $20 bills in brown envelopes anymore. So if you just want to like give me money, you can buy several copies of this book and just like buy the ebook so we don't waste paper. But, you know, whatever. But really, you should all be buying high-performance Spark. Python is covered in Chapter 7, and there's a debugging section in the appendix. It has such exciting things as a 400-line stack trace that my editor has not yet taken out. So buy it today before she notices. And it's an early release, which means that it's like you can't buy it in paper yet, so you have an option to buy it a second time in paper. And yeah, if for some reason you don't want to buy something that doesn't yet really exist, you can give me your email address to spam, and I'll spam you. Wait, oh, this is Europe. No, selectively contact you in compliance with EU regulations. Okay, I've got some upcoming talks. If anyone wants an excuse to visit any of these places, you can come find me. If there are any secret Scala people in the room, I'll be giving some Scala talks as well. If anyone wants to go to Barcelona, I'll be giving a talk there. They told me like I could say it, but not to tweet it. If anyone has like an idea of what I should talk about in Barcelona, like please tell me. Otherwise, I'll just like pick something at random. Yeah, cool. So that's pretty much it.